Hello, welcome back to my bench. Today is a look what I found at thrift store day. This is another one of those of my trips around the country this last fall that I found in a thrift store underneath the shelf way in the back, and nobody knew it was there. This is, you probably saw from the description there, and this is a neat little item that you just don't find in thrift stores very often, and it's in pretty good shape. So, without further ado, I'll open it up because you probably know what it is. Of course you do. It is a Heathkit tube tester, complete in the optional box. These came in a couple of different ways. They came sort of by themselves with a case around them, a little case around them, or they came in the box with the cover and all that. This one came with a box, and it's in pretty good shape. I mean, it's in nice shape. It has all of the buttons. Down here, it's got all of it's clean around the edges. There's a couple of spots on it that might be able to be cleaned off. And you can tell that this one is quite old. This one, I believe, is from 1963, I think. If we go and look at the manual here, I believe it is, yeah, right here. If you can see it, it's 63. So this one's been around for a few years, and guess what? We're going to find out if it works. So, anyhow, I do not want to turn this on first. I have not tested this. I don't know. I do not want to turn it on first. I want to open this thing up and make sure that there is no smoke-filled compartment inside, because I would not want to burn it up. And after all, folks, it is a Heathkit. If those of you who know me, some know that I used to work for them as a bench tech, fixing people's kits. But let's take a look at the front here and see what we've got. This is a basic tube tester. This is not one that'll actually put a tube through its paces and actually give you a good reading of whether the tube is actually or amplifying or dioding or whatever it's supposed to be doing for that tube. All this will show you is if it has emissions, if it is doing its basic function. That's it, which is normally plenty. It's fine. For 90% of what you want to test a tube for, this kind is good. If you actually need to test a tube to be sure that it will work in the instance that you are using it, you need more than this. But if you want to find out if you can get your TV running again, if the tube's bad, this is fine. This is basically what they had in the store. Only the store was much fancier when you took it into Woolworths with your bag full of tubes out of your TV set and plugged them into the machine and found out which one you had to buy. I remember those days. All right, so what do we got here? Basically, we have, from this side up, we have a line set. This lets you set the your variable line voltage. No line voltage is the same, but for this to be reasonably accurate, you have to have your line voltage set to a specific point in here, which, if we go over to the manual, you'll see is right here. It's a 100 ohm, 25 watt resistor. Come on, it's right here. That you vary on the input of the transformer. Transformer has, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 or 20 windings on it, and not including the input. So these are pretty you're not just going to go out and buy one of these. They're special, let me tell you. Anyway, so you've got, this is your input to vary the how much the voltage actually going into the primary. So you got that. Over here you've got your filaments. This particular one will go up to 115 volts. It's basically 110 actually, but it says 115, and I think that just telling you that it can go that far is close enough. You have an on-off switch. Over here you've got your plate load of different amounts, how much you're going to put on your plate as far as voltage goes. If we look at the manual again, over here, this is your plate. It's a 200 ohm, connects right to the plus side of the meter, which is a 0 to 1 milliamp meter, goes down through the switch. This is in line adjust. We want to show it here, down this direction instead of up there, and comes back up into this type of over here. It's a type of switch, which puts different resistances onto the plate itself in two different sections of that switch. This is a very normal. This is the way all of these old ones worked. It was pretty simple and nothing at all in the way of fancy. So anyhow, if we come back and look, this is your type switch. You got 4 positions. And like I said, this is a plate from 0 to 100. Those are arbitrary. And so is the meter arbitrary, by the way. Good means okay. Yellow means maybe. Bad means probably bad, but maybe not, depending on the tube. We also got on this thing several old style. That's why this thing is cool. It has the old 4-pin, 5-pin, 6-pin sockets, and the 8, 2, 3, 4, 5, 6, 7, 7-pin. And this little bitty guy here, which I don't think I've ever seen one of those. Plus more modern sockets over here. An 8-pin, 7-pin, octals, loctals, and a spare. If for putting in a new one, if you need it when you got it. So this one doesn't have that. And this one's also got something that's kind of cute. Right here, if you look in that is for testing light bulbs. You can take a little like panel lamp or whatever and stick it in there, put your filament voltage up to where your panel lamp is, and test it to make sure it's good, rather than just using a meter, I guess. Anyhow, let's open this thing up real quick and see if there's any thing that let go. Anything this old, you gotta check first. I know. Turn it on, watch for the smoke. No, you can't do that. It's just not kosher, not good. Don't do that. Get these out of the way. All right. Yeah, there we go. That's all 4 of them. And inside is nice and clean. Not much at all. And let's see how, well, wow. Ooh, as Dave says, that is definitely 60s smell right there. I'm telling you, that's pretty amazing. Reminds me of the good old days. So what do we got here? Well, we have hand point-to-point wiring done fairly well. Some things are a little iffy. If I take, I'll see if I can get some of these pictures using my phone here, because some of it's a little bit iffy. This right there. Of course, I suppose if you want to take a video, you have to actually hit the video button. Okay, so right there, not too good. Some of the soldering, he did most of the time go through the Heathkit. Make sure you loop it around and make it impossible for anybody else to work on it next. Which is a good idea, folks. Do it. It looks pretty good. There's a diode, I believe. Yeah. Got a couple of capacitors. There's a Sangamo type 33. Yeah, and there's all the switches over there for it. Look at that. Wow. Okay, well, it doesn't look terrible. Matter of fact, it looks just fine, and I don't see anything burnt. Let's see how the switches look over here. Wow, they're pretty nice. I'm amazed. Let's get back down with the camera again. Look at that. Look how clean those switches are. After all these years, this thing must have been handled very well. Put away nicely. There's a 0.1 at 600 volts. Here's that pot. This is this one should be, this one is the line set. You don't see many of these. This is a wire wound potentiometer, and I'll see if I can get a picture of this here. Make sure I get it right. There, it's wire wound. This right here, that is the connector that goes and touches the wire that's wrapped around the frame of this thing. And as you turn it, this connector, all it does is just hit the wires, and less wires or more wire depends on your resistance. This particular one is 100 ohms max. So that's how they used to make them. Cool, isn't it? All right, so I guess it's good enough. We can plug this thing in and see what we get. Like I said, I don't see any smoke. I wonder if the diode is any good. I know I can't show you this on the stupid meter because this meter won't go to, I don't know why. I have the source code for it. I suppose I could get in and fix that. But we're going to do a test on this. All right, so that is shorted. And where are you? You are red and yellow. Yep, 0.15 volts, that is correct. And the other way should be 1 and going up. Yep, it's correct. All right, so the old selenium stacked rectifier is fine. So we're good to turn this thing on as far as I'm concerned. So let's put her back over here like this. And undo this. And I am going to put it through the light bulb over here. I got a 100-watt light bulb, which is way more than this thing needs. But, you know, if it's shorted, at least the light bulb will come on. So we are on off. Here we go. Blink. All right, we're at what, 122 volts. And we're going to turn it on. Light bulb did not come on, but meter did go up, and the lights behind it. Wow, the dial lights work. This thing is in not so great shape. That connection goes up to either the plate or the grid of the tube, depending on what kind of tube you're testing. All right, so now basically we have to, there's your control. If you can see, it's all the way down and it's right on line test. That's because in today's, I've got this thing set at 120 1 volts. Let's go down to 100 there's about 120, so you would adjust it up. So that's important. You have to do that. All right, well, let's see if we can find a tube to test. Okay, so I found a tube. It is a 12AX7. This one's old enough that this will test it. I guarantee you there's some on here that you're not going to find. Anyhow, it is a standard little 8-pin, I think, right? 1, 2, 3, 4, 5, 6, yeah. 8-pin goes in here. We'll look it up on here, and according to this, it says I want to put my filament right down where we got the tube type. 12AX7 is type 1. Filament is 6.3, even though it's 12 volt, because remember that 12 volt in most tubes is split, 2 6.3s on either side. So we go 6.3 up there. And before I stick this in, we're going to make a measurement too, though. Plate would be 20. That's the load for the plate. Top going up for these switches. I've used these things a lot, which would be A and B go up, C, D, and E go down. All right, there you go. And we'll put it in there to test it. However, I want to, since it's available, I want to check and see what kind of voltage we've got here. I believe, yeah, this is going to be, I don't know, is this AC or DC? It is DC, I believe. .3 volts, 6.4 volts. Cool. So the transformer, at least on 6.3 volts, is correct. Fantastic. All right. Well, our line adjust is set. You have to do this for every tube. We got these guys are all set up to where they're supposed to be. We plug the tube in. Ooh, sockets feel pretty good. I don't think this thing really had a lot of use. Okay, we got no shorts. If the short lights works, and the tube is heating up, we are still on 0, or line voltage is good. And okay, what did I do wrong? Oops, switch in the wrong spot. Okay, it took it longer to warm up than I thought. I had this switch down. I don't know what that did. And it says that this tube is good. Fantastic. Well, except there are other tests you can do with this tube tester. Okay, I found it. It's interesting. Heathkit did this a lot in when you're testing, putting stuff together. They would actually put the how to use it right in the description of how to build it, which you had to actually look for. Oh, coffee's burnt. Nah. Okay, so let's get rid of the meter up there because we don't need it anymore. So basically what it says to do, it says put the thing in, check it and pull a button and see if it goes up to good. Okay, so then also you check the shorts by moving levers shown in light type through the two positions, returning to the positions shown in the chart. So you got light type, which is, in this case, A and B and C. A and B are up, C is down. So we check for shorts by doing this and watching this light here. Nothing. 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 Good. So we have no, as far as it's concerned, shorts. Now we want to test for open elements in this tube, which there aren't. This tube is good. Holding the slide switch in the test position, you move each lever in the top position, only those in light type, to the bottom and return them. Those properly connected to their pins are indicated by a change in meter reading. The grid element usually shows a large change, while the screen or plate shows only slight change. So basically what we're looking for is for this meter, from this test position, when I do, this was plate, I believe, A, and when I do this, I got a little tiny bit of change, not much. And when I do this, I should get a huge change, and I do because that's grid. Okay. So they're right on that. Okay. And I want to check the filaments, filament taps, and internal connections for continuity. So I set the filament switch to 0.75. Move each lever shown in dark type through its other two positions, only moving one at a time. Satisfactory filaments, taps, and internal connections will be shown by a bright glow on the test indicator, but in 0.75 volts because you don't want to take it out. So if I take dark, which in this case is D and E, that should glow, and it is. And it is. So all that's doing is it's connecting that to ground, or evidently through the connections, and that's it. So we have gone through pretty much all the tests for this, and we can prove that it's right. It also says tubes which contain several sets of elements are indicated in the chart by a bracket set of listings, and in this case, they definitely are. The 12AX7 has 2 tubes in it. So we need to redo this, take us back to the second set, which is 1, 6.3, 20, F and G up, because they're going to be around the tube. These are the tube connections here, basically. And D, E, and H down. So D, E, and H down. Let the tube warm up. And it's warming up. Because when I did the D, E, and H, I believe I just connected the filaments. So there it goes. So that's warming up. So on this set of tubes, on this tube also, we have to go through and check and see if there's any shorts. So we did that, remember, by going with the light type, 2-position light types, and pulling them down. So our light types on the 12AX7 second one is F and G. So F and G should not light the light, and it doesn't. All right, then we check for opens. We hold the test switch, move each lever in the top position, if they're light type, to the bottom, and return. Satisfactory tube elements, remember, will move just a little bit. So the top ones are F and G. That moved just a little bit, and that moved a lot. So that's good. We didn't actually turn this up, but it was very close. All right, so we have successfully tested that tube, and it's warm. Now, this should be fun. Okay, it's over here. Let's see if we got any bulbs that'll work on this guy. We'll find out what they are. I know I have bulbs. I got lots of bulbs. I got bulbs all over the place. Here's one. Old, like you had in the old lamps. So let's turn that down to there. Stick this thing in here and make it at least touch. And it's very bright at 5 volts. Wow. So that works. Testing your lamps works. Cool. Let's try one of these guys. I don't know what the value is here. Let's see if we can get this. That is also a 5-volt lamp, or 6, but very bright. So cool. Now I can test my lamps. What's this one? Take them back down. Ooh, that one's a 12-volt light. Neat. That is a T53. Yep. So, there we go. There you go, folks. Oh, wait. Let's see what happens here. This is a... Don't try this at home, folks. Whoa! That's a neon. As soon as I hit 100 volts, it's going to come on, but I can't leave it there for long because I got no dropping resistor. It works, one side of it. So you can even test neons. Don't let your fingers slip. If you're doing this at home, you're doing it at your own risk, because that could hurt you badly. Just don't do it. That was dumb. But fun. All right. Well, there we go. We have a working Heathkit, a subsidiary of Daystrom Inc. That shows you how old this is. Tube tester in my collection. I've got a good tube tester. I got several of them now, but this is a Heathkit. I want to replace that. I don't know what I'm going to do with this. I don't have any place to, display it. I'll just have to dig it out once in a while and play with it and be happy with it, I guess. Hey, thanks for stopping by, guys. Don't forget to subscribe. Hit that button down there. If you like what you see, give us a like. And don't forget, I've got a Patreon channel at AERV blog over on Patreon if you'd like to support me. And I want to thank my 3 supporters that I have now, which I'm very proud of. Thank you very much, guys, and we'll hope you guys keep coming along. So, till next time.